Okay, so let's look at unit 6, which is molar mass. So 1 mole of matter contains 6,02 times 10 to the 23 of its fundamental particles or elementary particles. You've done this already, okay? So by now you're starting to see this is quite important. 1 mole of an element has a mass equivalent to its atomic mass in grams. We've done that as well. 1 mole of a compound has a mass equivalent to its formula mass in grams. Done that as well. So now we've got to look at the relationship between molar mass and number of moles, because we know what 1 mole is. We actually want to know, sometimes we don't work with 1 mole, sometimes it's impractical because it's a value that's too big, or we don't need an entire mole of a substance because there's a lot of it, so it's impractical. So number of moles is equal to the number of particles we have divided by Avogadro's number. Okay, so N, number of moles, is N equal to number of particles, and Na is Avogadro's number. Of course, this is our constant. N, number of moles, is also equal to the mass of the substance given divided by the molar mass. So N equals number of moles, M is the sample of the gas, M is molar mass in grams per mole. Okay, so let's look at an example. I want to know how many atoms I have in 2 moles of sodium. So I know the number of moles is 2. I know N equals N over Na. I'm looking for N. Okay, 2 equals N over 6,02 times 10 to the 23. N is 1,204 times 10 to the 24 atoms. Okay, we've kept it as it is. So now I know how many atoms there are in 1 mole of sodium. I want the number of moles in 1.5 moles of O2. Well, N equals 1.5. Same thing as we just did. Okay, remember to get that on its own, I'm going to times on both sides by 6,02 times 10 to the 23. Now I put molecules because the question asked for number of molecules. Now they want the number of oxygen atoms. Oh, now we get to the fun part. In 1.5 moles of O2. So, I know that we have 9,03 times 10 to the 23 because we just worked it out. But I want to know how many atoms I have. So what we've got to remember here is oxygen is made up of 2 molecules. Okay, so this is not what I'm going to do. All right, so I'm trying to think. Okay, so 2 molecules, oxygen molecules. 1 molecule has 2 atoms. 1 molecule has 2 atoms. All right, so if I have 9,03 times 10 to the 23 molecules, I need to times by 2 to get the number of atoms. So I want individual atoms. You're going to have to go and think about that one a little bit. Okay. Now I want the number of moles of atoms in 96 grams of sulphur. So the difference here is I give you grams. We know that we want the number of moles. I get the molar mass off the periodic table. So it's 3 moles. Nice and simple. Now they want the mass, so little m, of 0.5 moles of H2SO4. All right. I know N. I want little m, so I'm going to have to find out the molar mass. We all know how to work that out now. 2 for the hydrogen, 32 for sulfur, 16 for oxygen. N equals m over m, so it's going to be 49 grams. Remember, grade 10s, it's really important that you write down what you know, okay? Because when you write down what you know, then you can work out which equation to use. So, you're now going to do activity 1 on page 196. The answers are on Teams.